Good evening, my name is Sadman Binzaman. This is EL6303, assignment 3, question number 1. The customer flow at a grocery store can be viewed as a Poisson process, defined as P, the number of customers in a given time span, 0 to t, equals K, which equals this, e to negative lambda t times lambda t to the k power over k prime. My apologies, k factorial. Part A asks us to find lambda. Suppose a probability that in 2 minutes at least one customer arrives equals 0.5. So the probability from 0 to t, from time 0 to 2, and k has to be greater or equal to 1, equals 0.5. There's actually an easier way to go about this. Rather than calculating when the probability of k is greater or equal to 1, we can just dismiss when the probability of k equals to 0. In other words, the probability from time 0 to 2, where k equals 0, equals 1 minus this part right here. In other words, 1 minus 0.5, which also in this case equals 0.5. Knowing in this particular case our lambda is undefined, what we have to solve for, our k equals 0, and our t equals 2 minus 0, which equals 2. Plugging everything into the equation, we get 0.5 equals e to negative lambda t times lambda t to the k power over k factorial. Substitute everything in, we get e to the negative 2 lambda times 2 lambda to the 0 power over 0 factorial. This thing equals 1. So we're left with e to negative 2 lambda equals 0.5. We take the natural log of both sides. We're left with the natural log of 0.5 equals negative 2 lambda. We can solve for lambda directly, and it becomes natural log of 0.5 divided by negative 2, which equals about 0.347. Part B of the question asks us to find the probability that in 10 minutes at least 2 customers will arrive. Another way to go about this question is we can take 1 minus the probability that 0 customers arrive, well, the sum of 0 customers and the probability of 1 customer arriving. The probability of 0 customers in 10 minutes equals e to negative lambda times t times 10 lambda to the 0 power over 0 factorial. This time we know lambda equals 0.347. We can substitute everything in. We get e to negative 10 lambda, which equals e to negative 10 times 0.347, which equals about 0.03125. Same thing with the probability of 1 customer. In 10 minutes. Same process, we set up our equation. We have e to negative 10 lambda times 10 lambda to the first power over 1 factorial. This gives us e to negative 10 lambda times 10 lambda. We substitute in our lambda, which was again 0.347, equals e to negative 10 times 0.347 times 10 times 0.347, and we get 0.1083. Our original equation asked us to find the probability that in 10 minutes at least 2 customers will arrive. Given that we know the probability of 0 customers and 1 customers respectively, we can subtract the sum of these two values from 1 to get the probability of at least 2 customers arriving. So 1 minus 0.3125 plus 0.1083, or 1 minus, that equals 0.86. 0.86 is the probability that in 10 minutes at least 2 customers will arrive. Part C of the question asks us to find the probability that in 1 minute exactly 1 customer will arrive. This part is a lot simpler than the previous. All we have to do is find the probability that in 1 minute 1 customer will arrive. We can define our variables right now. Remember, lambda equals 0.347. Our k is going to equal to 1, and our t is going to be equal to 1. So we can set up our value where e to negative lambda t times lambda t to the k power over k factorial equals what we're looking for. We can substitute all our values. E to negative lambda is 0.347, t is 1, times lambda is 0.347, t is 1, we can dismiss that, k is 1, over 1 factorial, we can dismiss that, and this gives us our answer of 245. Part D of the question is along the same lines as Part C. We have to find the probability that in 3 minutes, 0 customers will arrive. We can define our values again. Lambda equals 0.347. Our k is going to equal to 0, and our t is going to equal to 3. We can set up our equation. E to the negative lambda t times lambda t to the k power over k factorial equals what we're looking for. Do our substitutions. E to the negative 3 times 0.347 times 0.347 times 3 to the, that's in parentheses, to the 0 power or 0 factorial. That equals 1. We're left with e to negative 3 times 0.347. That equals 0.353. Again, the probability that in 3 minutes that no customers will arrive is 0.353. Thank you.